So pretty straightforward to switch from a normal HTTP connection to WebSocket to a WebSocket connection so we can use subscriptions with Apollo Client. Not too bad. And we've really got one half of our app working here, both our add song and song list components. But we have some important questions to answer at this point. We want to make these two buttons functional for each of our song components. When a user clicks on the play button, we should have that song added to our player, our song player component, and use React Player to actually play the song. So we need to figure out a way to get the data, to transport the data from this component all the way to our song player component. And we want to keep it in sync. You can see for the final version of our app, whenever we hit play for any one of these songs, the durations reset if it's a new song, and additionally, when we hit the play button here in the individual song, it's kept in sync with the player and vice versa. So there's a couple of pieces of state that we're going to be managing. First of all, the song that we're going to be playing is going to be one piece of state, and another piece of state is going to be whether the song is playing or not. And how are we going to manage this state across our components? Well, once again, we're going to use the combination of use reducer and use context. So let's begin by setting up our state management. And we're going to follow the pattern that we did in the past, which is setting that up within our app component. We're going to begin by creating some context, React.create context, and we're going to create in the initial object passed to it those two pieces of state. We're going to call the first piece of state song, and that's going to be an object, and then we're going to have a property called isPlaying, which is going to be a Boolean, and by default it's going to be set to false. So for our song data, we can just hard code these values, and we can grab any one of our songs from our database. So we can head to data, we can head to our songs table, and we can say grab the most recently added song. We grab the ID, the title, the artist, thumbnail, and the duration. Oh, and the URL as well. So this created context we're going to call song context, and we want to export it. So we're going to consume context up at the top of app with use context. We'll pass song context in, and we're going to get our initial song state. And we want to pass that initial song state to use reducer. So we're going to create the reducer in just a second. That'll be the first argument, and then we pass in the song state. And we're going to get back two familiar values, state and dispatch. And we want to pass those to our entire component tree. So we're going to add our song context provider in place of our fragments. And provide to the value prop an object containing state and dispatch. So let's create our reducer here, our song reducer. So let's make a dedicated reducer file, and we're going to call this song reducer. We'll make sure to export it before we forget. And it's going to accept state and an action, and it's going to switch cases based on the action type that it gets. So we're going to import song reducer. We can call this song reducer from /reducer, and then pass that to use reducer. So before we start thinking about our individual cases, let's just create a default type for song reducer that's just going to return the previous state, and take a look at where we're going to need to perform different state updates. So this should be pretty straightforward. When we have a song in our list and we want to play it, we'll hit the play button here. So if the song is not loaded already in our player, when we hit play, it's going to set the song and it's going to set playing to true, is playing to true. And if we toggle that, say when we have a pause button shown, you see that when we hit a new song, that song loads in our player and then is playing is set to true. That's why we see our pause button. When we hit the pause button again, that pauses our song, and that's another state update. So these are the primary state updates that we're going to care about, and those are going to be performed within song list and our song player. But before we actually perform those updates, let's pass a real song, the song that we have in state, or I should say the song that we have stored in context, to our player. So let's save everything and then begin by consuming context. So we'll go to song player, and up at the top we'll use context and import the song context object and get back state for now. And we want to display all the song's data within our JSX, so we're going to replace the hard-coded title with state.song.title. Artist will be state.song.artist. Then for the duration, we'll leave that alone. We'll see how to update that when we actually get our player working. And then we want to pass down our thumbnail to card media from state.song.thumbnail. And I believe that's it. So let's save and make sure we can actually consume that state. And we can. So next we want to see how to toggle the is playing state. When song's playing, we want to set is playing to true and show our pause button and our play button when we're not playing. So when a user clicks on within song player, the icon button within which we have play arrow, set up an on click, and we'll call a function handle toggle play. So this is going to use dispatch to dispatch an action. So we'll dispatch a new action which we'll create with the type play song. And we don't need to pass along any data since this is just a Boolean value. So we'll create a case in our reducer, case play song, and we're going to spread in to an object that we returned the previous state, and we want to set is playing to true. Simple enough. So once our action's dispatched, our reducer runs and state's updated, back within song player, state.isPlaying is going to be set to true, and we want to show a different icon. So within the icon button, we can add a ternary where if state.isPlaying is true, we want to show a pause icon. Otherwise, play arrow if not. So we'll make sure to import pause from material UI icons. And we'll also give it the class name classes.playIcon. So when we save, we can hit the play button and we see it's changed to the pause icon, but we can't change it back. We need to toggle it so that when is playing is true, we can set it back to false. And the way that we can do that within handle toggle play is we can add a conditional where we can conditionally dispatch a type according to state.isPlaying. If it's already playing, then we want to pause the song. So we'll dispatch an action with the type pause song. Otherwise, if it's not playing, we'll play the song. So let's create another case that'll just be the opposite of play song, pause song, where is playing is false. And then we'll see that we can toggle the play button just like that. And next we want the ability to hit the play button for each one of these songs and not only toggle it, but also set a song in the player if it doesn't already exist in it. And note that we're not keeping this state in sync with the songs in our list. If this song is playing, then we want to indicate that it's playing within our individual song component. and be able to toggle it from there as well. So we need to consume state back within our song list. And in fact, we'll do that in our individual song component. So we'll use context and pass in song context. Make sure we're importing that. From app. Then we get back our state. And here we can't include a conditional for our icon button that's used to play the song. We can't use a ternary just like we did before. If we tried to do that, if we tried to say state.isPlaying and show a pause icon, otherwise a play arrow, if we wanted to do that, then whenever the player is playing an individual song, when we hit the play button, all of the play buttons for every one of the songs are updated. We just want the appropriate song to be updated. So the way that we can check for that is with the help of useEffect, and we want to sync with a couple pieces of state, a couple of values. The first one we want to sync with is state.song.id. We want to identify a given song by its ID, and we want to check to see if the current song's ID from song.id, we want to see if they are the same. And what we can do is we can destructure song up at the top. So we can just say ID if ID and state.song.id are the same, as well as state.isPlaying. If all of this is true, then we can put the result in a variable is song playing. Is this particular song playing? And then we can create a piece of state which is going to be false by default. We'll name this current song playing, and the setter set current song playing. So if is song playing is true, then we're going to put that in state. Then back within our ternary, we can use the value current song playing. And we also need to add to our dependencies array state.isPlaying. And once we have all that, we'll see that our player stays in sync with the appropriate song. I think I included the wrong ID here. Give me 1 second. Yeah, I included the wrong ID. That's why it's not updating correctly. Okay, that's better. Now we also want to be able to update state from this play button. So we can just pull in from song player our handle toggle play function. And here, back within song list, we want to bring in dispatch. We want to destructure that, and we'll add handle toggle play, add it to that icon button, the play button. But remember that we, in addition to dispatching an action to pause or play the song accordingly, we want to first set the song in state. So first we want to dispatch another action in handle toggle play where the type is going to be set song. And the payload for it, we're going to need to provide the entire song itself. We'll provide it on this song property. And all the song data is going to come from the song prop that we're passing down. So to our reducer, we'll need to add a case for set song. And this is going to be really simple. We're just going to spread in all the previous state in our returned object. And we're going to set the new song to action.payload.song. We're just going to completely replace it. And when we do that, from any one of our song components, we now can see that the isPlaying state is syncing with the changes that we make over here. And also when we attempt to play a new song, that song data is immediately loaded into the song player. So using useContext and useReducer, we're managing our song state across components, but we haven't covered how we're going to update the queue. In the final version of our app, we saw that we have a queue, a kind of playlist that we can line up, or we can line up songs to play after the current one, and we can add new songs to the queue by hitting this Save button, and we can remove songs from it with the Delete button here. Now, this isn't being managed using useContext and useReducer. And the reason for this is the following. If we refresh the page, you'll see that this queue stays here. The queue is persisted, but it's not persisted in our database. This queue is actually being maintained or kept in the browser using local storage. So not only do we have a way to manage our global app state, when we update this queue, you see that we're managing our app state in some way across components, but we're also syncing it with local storage. We're also syncing it with the browser. We're going to introduce another way to manage our app state, but what's neat about this approach is that we're going to see how to do so with the help of not reducers, not React itself, but with Apollo. See, one drawback to using reducers and using something like Redux, which also relies on reducers, is that reducers are pure functions. We can't perform side effects. We can't interact with the outside world with them. So it's not the best setup if, for example, we want to make an API call, or if we want to work with the browser. In this case, we need to do so for the sake of maintaining that queue. However, a neat thing about Apollo is that it comes with a built-in state management system, one that we can set up in our client, and we can use with the familiar Hooks API that we've been relying on so far in building our apps. So this might seem a bit strange, but we're going to see how to perform mutations and query for things locally without making a request to an API. So let's just quickly review where we want to use this. We want to use it in two places. We want to be able to add songs to our queue by hitting this Save button, and we want to remove songs from it using these Delete buttons. And we're going to query for the items in our queue in the queued song list component. So we're going to see how to create an individual query to query for our queue, and then a mutation to be able to appropriately add or remove an item from the queue. The save and delete operation is really the same. So we need to tell Apollo client about the state that we want to manage. And we do so with a new property on Apollo client called typedefs, short for type definitions. And this is something that we write with GQL. This is something that Hasura has been doing for us automatically, creating these typedefs for us, creating this schema for us. We need to create a schema to tell Apollo what we're going to be querying for, the data itself that we're going to be querying, the structure of that data, as well as any mutations. So first we're going to begin by describing the type of data. We're going to create a type, an object type called song, and it's going to follow exactly the structure of our song that we've described to Hasura and we've put here within context. So we know all of these fields. We know ID is going to be of type UUID and required. Title is going to be of type string and required. Artist of type string and required. Thumbnail, string and required. Duration, float and required. And URL, string and required. So looking at our queue, we don't necessarily need to include all of these fields, but just for the sake of completeness, I'm going to include everything on our song. And then we need to specify a query. So we're going to create a type called query. This is a root type. This is a type built into GraphQL. And here we can create a field of it. Think of this as a kind of custom object type. And we can name the query that we want to perform. So we're going to call ours queue. We could maybe also call it queued songs if we wanted to, but I'm just going to name mine queue. And this is going to return an array of type song and required. This exclamation point just means that we need to return at least an array, not a null value. And next we want to make another root type, extend another root type called mutation. So this is going to be the mutation that enables us to add items or remove items from our queue. And we're going to call this add or remove from queue. Now this is going to take some arguments. We'll get to that in a second, but it's also going to return an array of type song and required. So I want to introduce you one more GraphQL concept that's going to make passing arguments to this mutation a lot easier. Instead of having to list out all of the individual arguments like we did in a previous mutation like this, which can get kind of tedious, we're going to create a custom type called an input. So instead of creating a type here, we're going to make an input with the input keyword, and we're going to call this song input. So song input is going to be a kind of object that we can use to collect all of the individual arguments that we're normally passing to a mutation. Or it can be for any GraphQL operation really. And this is just going to be our entire song. So this is going to be really easy. We can just copy all of these values and paste them immediately into our song input. And then that means instead of having to list them all out here between these parentheses when declaring our mutation, we can just collect them all on song input and have it receive that song input on a single argument called input. And we'll make that required. So we've defined to Apollo exactly what our song data is going to consist of, that we're going to be managing, how to query our data, and how to make changes to it. But how do we actually add the data itself? We're just going to be starting out with an empty array. We're not going to have anything here. So we need to initialize that. We need to kind of initialize our queue. So we'll do that for now just by creating a data object and on it making a queue property. And note that it has the same name as our query. Queue is going to have just an empty array on it. And the way that we give our client, our created client, this data is we just say client.writeData. And we'll pass data in as an object. So the neat thing about this now is we can use our created query. So naturally we would want to use that here within our queued song list component. So let's go there. And actually I'd say first we want to write out our query. And we'll do so once again with GQL. We write out our query for the client just like we would for one that's executed over a network that's performed using a network request. So here we can say GQL, and we want to write a query maybe called get queued songs. And we want to get our queue, and since queue is an array that consists of elements of type song, which is an object type, we can select all the subfields off of song. We can grab ID, duration, title, artist, thumbnail, and URL. Now, one important thing that we need to add here is we need to add an annotation that tells Apollo that we only want to perform this query on the client. So after the name of our query that we want to perform, after the field, we say @ to write an annotation, and this will be a client query. And once we have this written out, we can put this in a variable called get queued songs and export it. Now let's export this within queued song list. So we can bring in, actually I take that back. We want to execute this within song player, and we'll pass the result down to queued song list. So up at the top we'll bring in use query, bring in get queued songs, and then we'll get back in our familiar object data loading an error. But generally speaking, we really only need data. We shouldn't really ever have any problems getting our data immediately when performing a local query, a client query. So let's pass that data down to queued song list. We'll create a prop called queue and pass down data.queue. And then within queued song list, we can destructure that queue. And right now, let's just console log that queue prop. Let's save everything and make sure we're not getting any errors. And looks like need to import GQL up at the top of client. And once that's done, we'll take a look at our console. And right now, we have an object, the property Q, which is just an empty array. So we are successfully querying data locally with Apollo Client. Pretty neat. Now it would be better if we actually had some songs in our array. So let's see how to add them with the help of our add or remove from Q mutation. We're going to first perform this here within our song component. So let's go to song list, and we'll go to individual song component, and we'll bring in use mutation. And we're going to write out our mutation in the mutations file. And as we mentioned, as compared to using all these individual arguments like we did for add song, we're going to write a much leaner mutation. So we'll write a mutation with the name add or remove from Q, where we have a variable input set to the type of song input, like we declared in our type defs, and the field was add or remove from Q, just like this. And to the input variable, we're going to pass what's stored on the input. To the input argument, we're going to pass what's provided on the input variable. And again, we need to annotate this with client. And we're going to export this and name it add or remove from Q. So we'll bring that in to song list. And we can get back a mutate function. And when do we want to perform this operation? Well, when we click on the save button. So let's make a function called handle add to Q, or handle add or remove from Q. And that's where we're going to execute this function. And we want to connect handle add or remove from Q to our save button. So we've done all this. This is a pretty familiar process at this point, and we're going to have this mutate function accept variables object, and variables is going to consist of just this input argument, this input variable, and on it we're going to spread in all of our song data. So it can spread it in like this, but we're also going to need one additional property that we really haven't discussed before, but you might have seen it sometimes within the console when we're running a certain operation. When we run a new operation, you might have seen the type name field right here. And this is basically just a field which provides the name of the type that we're working with. So we can say underscore underscore type name is set to song. We are adding a piece of data that corresponds with the custom song type that we declared. So all this is well and good, but we really haven't specified how we're going to add or remove all of the song data from the queue. So we're providing all the data that we need to these individual arguments listed in the input, but how are we going to use that data that's collected on this input argument to actually add or remove an item from the list? Well, we can specify that after this typedefs property within our client file. We can specify that on a new property called resolvers. As its name implies, it determines how our different queries or mutations are resolved to a value. So on resolvers, we're going to have a mutation object named just like this, capital M mutation, corresponds to the type that we extend. And on it, we're going to have a property add or remove from Q. And this is going to be a function. We're going to specify how the data that we receive on input is going to turn into an array of songs with the appropriate value. So we get 3 arguments here, 3 parameters here within our function. The first one we can ignore, it's not important for us. The second one is going to be all of our arguments. We just have 1, the data provided on the input argument. We want to destructure that since all these arguments are objects. And then the last one is going to be the cache. So we can work directly with the cache to take what exists in it currently, just an empty array, and add this new song that we're getting, or remove it appropriately. So if you recall from working with mutations, when we want to update the cache, what do we need to do first? Well, we need to read from it. So we say cache.read query. We want to read the query in particular of get queued songs. We want to get all the previous songs. So query is going to be set to get queued songs, which will import. So this is going to return to us a query result. We could call this data. I'm going to call this query result, and we want to check to see that we actually get a result. So if we have a query result, then we're going to directly manage that data. We're going to update it appropriately, and on query result, just like we saw within, what was it, song player, where we executed that query, we had a data object, and from it we had a queue property. So on query result, we can destructure the property queue. So now we have our queue array, and if an item's already in our queue, we want to remove it. So if an item's already there, running this mutation again is just going to remove it. Otherwise, if it's not there, it's going to add it. So we first need to check to see if a given item, according to its ID, we need to check to see if it's already there. So we're going to get our song data from the input, and we're going to take the queue and say queue.sum. We want to see if there's some element in there where the song that we're iterating over, each of the songs, if any one of them has an ID that's equal to the ID that we're getting from the input. And we'll put the result in a variable and say is in queue. So if an item's in the queue, we're going to write a ternary here, and we're going to say if that's the case, then we want to remove it. So we can take queue.filter, and we can filter through that array and say we want to make sure that the song's ID is not equal to the ID that we got from the input. We want to remove that song. Otherwise, we're going to add this new song to the end of the queue. So we can spread in all of the previous queue's elements into a new array and add the entire song through the input at the very end. And we can store the return value of this expression, the return value of this ternary, in a variable which we'll just call new queue. So we've done 2 of the essential steps: read from the queue, read from the query, and then manage that data, directly update that data. We just need to write back those changes finally to the query that we read from. So we just need to say cache.write query. We want to write to the get queued songs query with the data in which the queue property is set to new queue. And we can assume that process is successful, and we just want to return from this. Remember, we have a return value for our mutation. We want to return the new array of songs. So we can return new queue here. Otherwise, if we don't have a query result, we're just going to return an empty array if we can't read for whatever reason from this query. Now let's see if we can put this all together. So we have the functionality of this mutation created in our resolvers. Now let's see if we can execute this mutation when we click on the Save button. At the moment, our queue is set to just an empty array, but if we save one of the items, the queue now consists of one element, one song. If we hit save again, that item's removed. And if we add another item, that item is added. And if we add additional ones, we now have 3 items in the queue. So this is working successfully, which means we can pass this data down to our actual component to display the real data instead of the dummy data. So now that we have our queue, we can remove the hard-coded song that we have here, and we can map over the queue from the queue prop and say queue.map, and then we can display the number of items that are in the queue by simply taking the queue array and then grabbing the length property off of it. So once we save that, and we'll make sure to interpolate that expression queue.length. When we add items, when we save items to the queue, we see that they immediately show up here. And now to make our delete button functional, to delete a given queue using the trash can button, the delete button, let's go to the queued song component. And all we have to do is, for the delete button, the icon button here, you can just add an onClick, which is going to execute the same function that we called back in song list. And that was the handle add or remove from queue function. So we'll reference handle add or remove from queue, and then paste that function in the queued song component, and we'll make sure to import both use mutation, then the add or remove from queue variable, and we'll get back our mutate function. So when we execute this mutation upon clicking the delete button, after hitting save and adding a given song to our playlist, we can also remove it whenever we hit the delete button. And finally, the whole benefit of using Apollo state management as compared to use reducer and use context, that way of managing our state, managing our global app state with the help of reducers, is that we wanted state management that didn't confine us to just using pure functions. We wanted to be able to perform a side effect so that we can save our queue in the browser, so that when our app loads, the queue items that we've saved are taken from the browser, in this case the browser local storage, and then displayed back in the queue. In other words, we want our queue to be persisted. So in order to do that, we need to take the items that we've added to the queue, take the data from the mutation, and then find a way to put that data in our browser's local storage. And I believe the most convenient way to do so is whenever we save a given item in song list using our use mutation hook, we can use the second argument to it and access the onCompleted callback. The benefit of this is that in the parameters of the callback, we get access to the data. So we can write an inline function here. OnCompleted gives us the data from the executed mutation, and taking a look at our client again, we see that our mutation returns our array of songs, the new queue. So we can take that and say local storage.set item. We want to set a new item where we'll call the key queue, and we want to put the data, the return data from the mutation, that will come from data.add or remove from queue. That's what we want to set as the value, which corresponds to this queue key. Now, since this is going to be an array, our queue is going to be an array of songs, and local storage only accepts string values, we're going to need to use the method json.stringify to convert our array into a string. So we'll pass our returned array to json.stringify. So whenever we save an item to our queue, we hit the save button, the item still shows up in the UI in our queue area, but if we look at our browser's local storage by going to Application, the Application tab, we see this new key with the name of queue that has the resolved value of the mutation stored as the queue's value. And additionally, we want to persist any changes whenever we delete one of these items from our queue. So we can just copy this onCompleted callback and head to queued song list and provide that as the second argument to the same mutation. And then the last piece of the puzzle is when we first load our application and we write our data. Remember, we are writing this data object to our client. We are writing this data to our cache. Here's where we want to get all the items that have been saved in local storage. So to get them here within client.js, we need to first check and see if we have a queue. So we'll make a variable called hasQueue, and we're going to say local storage.getItem. We're going to try to get an item with the key of queue. And we're going to convert this to a Boolean value. So hasQueue is going to be either true or false. If there's no item in local storage with the key of queue, it's going to return undefined, and therefore hasQueue is going to be false. Otherwise, if there is an actual array associated with it, we're going to get a value of true for hasQueue. So we can write an inline ternary here where we're setting the queue property on data. If we have a queue, then we want to say json.parse, which is the opposite of json.stringify. We converted our array to a JSON string. Now we have to parse it back into a normal JavaScript array. So we'll pass local storage.getItem queue to json.parse. Otherwise, if we don't have a queue, we'll just provide an empty array here. So at the moment, if we look at our app, if we look in our application tab, we see that we have a queue consisting of two items, these two items here. And when we save these files and our app reloads, those items are taken from local storage, put in our cache, and queried using a local query and put in our queued song list component. And we'll continue to persist these data changes whenever we add new items or remove old ones. So using Apollo as a local state management system as compared to using just React and the hooks that we're already familiar with might have been a bit confusing, but hopefully you see the benefit of it now. Not only does Apollo help us fetch data from outside our app through network requests and WebSockets from a GraphQL API, but it's also very powerful in enabling us to manage state locally and do useful things like help us store data in the browser. And what's very convenient about using Apollo to do this is that we don't have to change how we think about our data. Whether we're fetching data outside our app or managing data within our app, we can still use GraphQL to help us, as well as all of the essential hooks that Apollo provides to both get and change our data.